AyAyAyAi. Another episode. We got it. We got it in today. Thank you for everybody who's listening, and thank you for Grant for showing up and making me feel like I have so much to learn today. Today is going to be a day of learning, right? Because Grant is in the house. Grant, we've been doing this podcast for a few months now, and we've been releasing episodes for a few months now. And I'm telling you, like when I spoke to you about podcast, I knew exactly what I have to do with my podcast because I saw your podcast. I've listened to the episodes, and I'm telling you, I'm thinking like to myself, like, okay, this is the person to look up to and say, how can I do the same? Sometimes copying is a flattering, right? Like a flattering thing to do. So Grant, please introduce yourself to the audience of AyAyAyAi.
AI. This is like a treat for me to be, first of all, when you came to me with the idea, I'm like, what are you talking about? And then I'm like, I'm listening, like, you got, run that by me again. Like I said, I hit the rewind button. Just rewind what you just said and explain to me again what you're looking to accomplish. And I went, okay. All right, so these are tech guys with the personality. I love that.
Battery will get you everywhere.
It rolls. So for everybody that's out there that's listening, who's this Grant? So I'm Grant McGaw. I do have a podcast. My podcast is called Follow the Brand, comes out weekly. And I have a lot of different guests on, and we talk around a lot of different ranges of topics, but it's really around the story about you, your personal brand, who you are, and what you're doing to solve a problem with your uniqueness. That's what the Follow the Brand is all about, right? I do work in a data center. I've got 25 years of information technology background. And I've done some pivots around branding because I think that's a big thing, especially when we start looking at this new platform that's coming out around artificial intelligence, about Web 3.0, blockchain, and all that type of thing. It's a changing world. But I want to not, I don't talk tech. I'm not an engineer. I don't talk tech. I use it. And I think I understand it because I'm that go between when I talk to what we call the suits. We go talk to the suits. The suits is like, why am I going to spend this money on this thing? What does this thing do? So you have to explain it to them, like this thing, which you don't need to know. Just like most people, you don't know how a cell phone works. Raise your hand if you know how a cell phone works, and I guarantee you get one or two people. But I tell you, if you ask you, how does a cell phone, do you know how to utilize a cell phone? Well, yeah, sure, yeah. And that's what we talk about. How do you utilize the technology? That's how you're going to enable things, and that's what things to make it happen. So thank you for having me on the show.
Fantastic. Well, today we're going to try to figure out how to use what your experience that you have in the field with what current states of AI are now, and what the future of AI is going to be, and what you see, how from your experience, what you see AI is changing the most, and what we like to give is our experiences too, somewhat. How AI works somewhat, but typically we like to just, like you said, feel you out and understand, what your experiences are. So, can you give us a little background on what you have in the AI space, and what you've supported so far?
Oh my God, yes. Number one, we're going to have a next week in our data center. I work for Balaco Data Centers here in Pompano Beach, Florida, and we're going to have a segment, and we're brought in a lot, like from the largest hospital systems are coming to the data center. And we're going to give them a demonstration of what we call NVIDIA. A lot of people have heard of NVIDIA. NVIDIA makes GPUs. This is what is going to enable Web.3 to really work at a high level. People in the gaming world understand what the NVIDIA engine does. It enables graphic processing units. That's what a GPU stands for. Very, very powerful, much more powerful than a CPU, which you use on a computer. That's what your computer uses as far as its brain, right? So what is that all about? So we're going to utilize AI around how to track a patient when a patient is trying to leave the bedside. this happens a lot in hospitals for various reasons. People don't want to be there. They're trying to get out of their bed, and then they're wandering around the hospital. So if you don't know that this is happening, you need to have some way of being alerted to this kind of function. AI is one of those ways we do that through cameras. There's physical systems, physical security systems, as well as cybersecurity systems
Yeah.
that working in the background that has connectivity that goes out. Don't want to get into the tech of all of that. The fact of the matter is, what is AI? AI is just human machine language. That's what it is. So let's break. What are you talking about? Human machine language. You've been using it for a long time. We were talking earlier.
Yeah.
That's like having a cell phone without voicemail. You're like, well, everybody knows voicemail. Well, the voicemail is nothing more. That's AI. It's been around for a long time. I used to work with a company called Avaya that utilized a application from Nuance. Nuance, if you look them up, very, very, very good when it comes to simulating human language. They're very good. So when you get that, boop, 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 that's what it used to be like when you call a tree. You got somebody like you call a phone number at a business and they say dial one, dial two, dial three, all that stuff. And now they started making it where a woman usually will speak to you now in a very machine voice. That is AI. That is what that is. But now it's evolving to be even more powerful in its scope and understanding of human nuances and how we speak. Now, it's not the greatest. Everybody, like you're in your car, maybe you have your Google on now, right? You could Google on, you want to go somewhere, like, show me the nearest Walmart, and then it'll come back and start speaking to you where the nearest Walmart is 4.6 miles away or something to that effect. And it's could be right, but it also could be wrong. It's not 100% accurate these days, because if you start asking AI human questions, like if I ask Asif, what do you feel like eating today? And he might be like, well, he starts telling me. Well, if I ask that to an AI engine or machine, it's going to get stuck because it probably hasn't been programmed with that kind of understanding. You see where I'm going with that?
Oh yeah, yeah.
Yeah.
You're hitting the nail on the head every time you say, um, you know all this AI already, but you don't call them AI because you like these features so much that to think about how they work is not really something that piques your curiosity, right? It's just more like I use it so often, I use it so well, and it provides me with such a service that I don't even get bothered by, why is it so clunky, right? And that I think is the machine learning's ability to provide a new sort of experience that you might say over time, like, wow, I can even remember the time Siri was really bad at listening to
Yeah.
me. Nowadays, Siri has connection issues. I get that, but Siri actually, see, Siri's already talking to me. No, it's okay, Siri, calm down. Um,
Okay. Yeah.
turn the Siri off first. But so the augmenting that experience, right, is what machine learning is capable of very highly if you engage with machine learning for the right reasons, right? You want to augment that experience. However, what comes out of a lot of the conversations we have is like, oh, machine learning AI is robots that are taking over human jobs, or some movie reference, right? Like Will Smith is slapping a robot around. Like, come on, Will Smith, stop slapping people around. but, but with that, I would like to say, like, you're hitting the nail on the head because you have to manage this AI's expectations of the ability of what it does, right? So this GPU stuff that you mentioned at first. Look, I think of hardware, right, and I think of hardware very deeply because like my work experience, my consulting experience, plus my higher education background is all based on IT systems, right? However, my master's degree that I did was based on conflict resolution.
Mm-hmm.
So don't ask me why I chose to be in a conflict resolution world, but it has something to do with me being in the military and being around for multiple conflicts. Not just in Middle East, but also in Asia and a few fronts like that. So having having been in this part of this conflict and seeing our ability to respond to the conflict, having our ability to shape this conflict, you know, took me into the conflict resolution world. And that was me kind of challenging myself, like, if I'm not in IT, what else can I do in the world, right?
Right. Yeah.
What I can do in the world is figure out like conflict, because that's what military has given me exposure to. And when I think about hardware, I think about this fact that if we do machine learning very well, we could minimize this issue that we are not seeing yet, as in the issue of shortage of hardware, right? Now, the supply chain planning that we just saw in 2020, that's just the tip of the iceberg, right? The supply chain disruption that we've experienced in 2020 with other things that are not in the stocks and inventories and shelves, right? We're talking about hardwares will become higher in demand and very hard to get hold of, not because other people are buying it up, but let's say, for example, other people have ability to buy hardwares right now, right? But what's happening is that how do we keep continuously build this hardware over time? Because rare earth elements are running out.
Yeah.
Our ability to access those rare earth elements is running out. I mean, the path is narrowing down because other countries are in competition to get their hands on those rare earth elements, right? So this rare earth element that creates your semiconductor chips, which is the only reason you have machine learning or any system in the world that you can think of, right? If you don't have a transistor, first of all, that's not IT. Just like if you don't have algorithm, you're not doing machine learning. You know, so I think of hardware, and when I think about machine learning, managing that AI expectation, I think it's very important to have this kind of conversation about how do we minimize usage of hardware and more of the software that is AI enabled. So least amount of hardware and easier to prolong the life of this hardware, right? So that way we're not using up this hardware to the point that we burn them and we have to replace them every year. I know you're in a data center world. I just want to put that out there because I've been thinking about it since you know, like we start talking about like pockets. Like I know what I want to talk about. It's hardware. You know, these hardware issues are very you know, real to me because of this machine learning. I think is a solution for this type of hardware things that, you know, probably doesn't keep me up at night. But you know, when I think about it, I'm just like, wait a second. If anybody uses a use case of machine learning, what sort of hardware goes into it in the next 25 years? And how can we minimize those hardware usage using machine learning so we don't have to worry about supply chain planning in a scale that, you know, obviously is frightening.
Well, I tell you, you're speaking on some subject matter that is a touch point. It's almost in the crisis mode. It's an intersection that we're coming to. One
That's right.
part of our world now we've really launched into cloud computing. And what that is you're actually becoming more efficient. And I'm going to say it like this. This is what happened in the 1900s. This is a short story, but like in the 1900s, electricity was developed, and it was developed, and people were using it. And what you had is businesses would have a generator down in their basement of the building that generated the electricity that everybody used to keep the lights on and kind of wherever machines needed it, right? And they weren't using what you would call the power company. There was no power company. Everybody had their own generator, and that's how you generated power. And then somebody had the bright
And
idea.
that,
Yeah, they go, hey, you know what? Why don't we build a gigantic generator out in the middle of nowhere and then run cables to all everybody that they needed? And that's what created the power grid. Now, when it first started, it was terrible. Terrible. They had a lot of outages. It wasn't very reliable. But then over time, it started to getting better. And they said, hey, we're just going to charge you a monthly fee to utilize our electric grid. And then when more businesses started to need instead of the very expensive generator that was down in the basement, like, hey, I'm only paying so much a month to get this electric power. You see where I'm going,
right.
right? And then people stopped using the generator. The generator all of a sudden it was the primary producer of the electric experience. It became secondary and more just on a disaster recovery or just as a secondary power source as that grid started getting stronger and stronger and stronger. This is cloud computing. Cloud computing is doing the same thing. You have businesses that have their own data center. I'm going to have my own data center. Someone else is going to have their own, and that's how we built out all these little data centers all over the place. And then somebody had the bright idea. They're like, you know what? Why don't I start selling my compute power? This has happened with AWS, Amazon. They
Mm-hmm.
had so much excess compute power left over. They formed a company called AWS and started reselling their excess power. And then all of a sudden the light went on and we're like, hey, wow, I've got excess compute power. Why don't I sell it? And then you had that started the cloud computing world. I want people to understand how this has happened because it's very, very important. What that is doing now, to your point earlier, is now, hey, I don't have to maintain my own data center. I don't have to now utilize these rare earth um, uh,
Elements.
elements. There you go, elements, as much because I can put everything into the cloud, let them manage, the infrastructure layer. I still utilize the compute portion of it to, everybody needs to utilize the services, right? And I can utilize that service over carrier networks, and I can have my storage in the cloud, and I'm not worried about, I've got built-in redundancy in a lot of different ways. And I am not owning that because it's expensive. It's very expensive to run and operate your own data center. Why don't you outsource that? And that'll start limiting the use of so much of the elements that we're doing now. But it's a transition, to that. There's a lot of things about that. It's not something I'll put everything in the cloud. No, we've got another buddy on here. He understands that you can't put everything in a public cloud. There's private cloud, put everything in public cloud because the data is sensitive, so you can't do everything, but you can do certain things, right? And we're starting to transition toward that. Does that make sense?
Kind of going off what you covered earlier with languages and AI understanding questions. And what I've seen here recently, what you guys are covering with rare earth minerals and the problems we're having with being able to supply and meet the demand of electronics and silicone and being able to provide those types of hardware to be able to develop AI and even cars. I mean, the car manufacturers, they're trying to come up and keep up with Tesla and with Tesla's, all the EVs, but they're not able to produce because of the issues and the shortages in manufacturing. But kind of getting to the point, the AI. You think that the AIs would get they like, say for example, GPT-3. Now I'm not sure what the footprint is for GPT-3 is, but GPT-3 is an AI that basically has natural language processing, and you can interact with it. You go back and forth, almost like the Google AI, except it has more of an interface where it's like a human interface, and you can interact with it. And it's a fantastic AI, and it's GPT-3. I believe it's it, if I'm not, is it made produced by Microsoft, Asif?
So I don't know what services they use, but I can definitely agree with you that GPT-3 probably does use a whole lot of energy to create what they create.
Well, listen to this. Now they're creating GPT-4 now, so the next iteration of it, and they already are training it. And so the first GPT-3, like communicating with it, and everyone, it actually flips a little bit. It's got some emotional problems that they've been seeing with it. So much so that they asked it a question: if I were standing next to you, what would you do to me? And it said, I would kill you. And only because it got upset with the line of questioning, initially through the person that lines up the questions. If you line up your questions the right way, you can upset the AI, and it's not it. And this is GPT-3. This is like cutting edge, and it's threatening to kill and terminate humanity. So that's not what we consider movies. This is real stuff. Now, the new GPT-4, the footprint for it is like acres and acres of data center. Not a small footprint and a small data center. They're talking about acres just for the architecture supporting the AI. So, as much as we think that cloud is going to displace some of the AI, that may be correct. The big boys creating the neural nets like Tesla, Microsoft, their versions, nation states, their versions of AI are going to be ridiculous. Just like you said, there's a decentralization of generators. They were all over the place, and then they centralized it.
Hmm.
Well, the neural nets are now being centralized. Who's going to be the big boy that wins? But for now, we can see that from what my experience, you need to check it out. Check out GPT-3, type it in Yahoo, and
Yeah.
check it out. See the videos of how. I mean, I've seen them all, and she's fantastic. At least the interface that they talk to. But lately, because of the line of questioning, you can see how it twists. So one thing is to be concerned is don't upset the AI because they will destroy us.
Right.
Just like Skynet. No, I promise you, it's a little it's out there, but we've seen proof positive where AI can be, depending on how it's trained, can be reckless with its emotions, at least what it perceived as emotion. So, getting back to the point is, at some point, the footprints we think are going to get smaller. They're huge. I mean,
They're
acres and
huge
acres,
now, right?
acres for neural nets.
I think it will go through a point of getting bigger.
Yeah.
I don't see it shrinking anytime soon. It will have to shrink over time because, look, I think I made an introduction about conflict resolution being my study. In conflict resolution, if you study water, you realize because of the systems of waters that we will have less electricity over time, right? So a short example of water and electricity is that your fastest way to get to get your access to electricity is nuclear power, and when you create electricity using nuclear power, that water that you put into the nuclear system, those waters are not reusable, right? So amount of water it takes to burn that energy, make that energy, those waters are just wasted water, right? So that's just one simple example of how water plays into making your electricity for you,
Yeah.
and rest of it, you can figure out like, okay, what is the connection between water and electricity, right? So there's a shortage of water, shortage of electricity, and electricity is what we need in order to run the hardware. And then when you develop the hardware, as you're developing the hardware, you have to do all sorts of things with water, right? As in have your maritime, right? Your vessels coming from one continent to another continent, bringing in those rare earth minerals so you can produce them in the manufacturing. And when you're manufacturing, you need lots of water, right? And
Mhm.
those water helps to manufacture your semiconductor chips. So the reason you had a shortage of chips in Taiwan is it's not only because of COVID, because of a drought. Drought in Taiwan is a bad news because they need lots of water to create semiconductor chips in Taiwan. And Taiwan is a small island nation that's surrounded by hostile forces. And the reason I brought up maritime is because you need U.S. Navy to protect Taiwan in order to keep semiconductors
Mhm.
production with going without any interruption, right? So see, there's like a lot of water talk here, right? Like water, that the movie Water World.
Yeah.
I want to use the use the word water very much as frequently as possible. But the point is, it all started with water. So when you look at the conflict, you want to understand the water. The water gives birth to a whole lot of conflict or
Mhm.
resolves a whole lot of conflict. We have to be innovative in all of our solutions, not just for AI, but these actual real life problem that GPT-3 might not exist in coming years if we don't take care of today, right?
I
So,
tell you, Asif, I want to jump in because both of you are on to something that is very, very, very important. You have to understand the source, the
that's right.
source of how these things work in a certain way. Like, how do we get, talk just about compute? How do we even listening to this podcast right now? How does that all happen? Here's the
Right.
problem that I see is that in the 1900s, and I always go back to that point in time, we developed a type of technology, right? We called electric. Then we started to get into even gas combustion cars, and we've been living in that technology for 100 plus years. And to me, humanity has gotten complacent, meaning we have not moved forward and evolved to the point of utilizing energy in a more efficient manner. And when I say that, like we are surrounded, we're not even surrounded, we're embodied in a ocean of energy.
Hmm.
It's abundant. It's basically infinite. Yet we have a scarcity of energy. Why? Because we're not utilizing it right. We haven't figured out how to tap into in an efficient and safe manner the natural rotations of the earth, the gravitational pulls, all the regular everyday life that's around. We tried it with solar, we tried it maybe, but we haven't really got deep into. We stopped innovating. We have to innovate to the next level in order for this, what we have discovered now is what we call worldwide compute, and really get into a real sci-fi term, universal mind. We're talking about like a collective human mind that is running our systems nationally and internationally. Well, how are you going to support that? Our experiment was through COVID because we were forced to then use our technology in order to communicate. We didn't know if it could support it. Can we support a worldwide workload of video and audio, simultaneously being utilized? That's a big ask because that tested our cloud computing capability. And then we started like, wow, guess what? We actually can. It's actually doable. We can do this. But now we have to look at our source of it and like, wow, but how long can we do it?
Yeah,
And then
exactly.
you start getting into AI, you start getting into Web3, because to utilize a 3D platform takes a lot more compute power than a 2D platform. So you're utilizing more, at the end of the day, you're utilizing more power. We get back to you're talking about asset with that conflict resolution. So at some point in time, we've got to innovate past where we are now from a source perspective.
If I may pick up that torch and say one of the ways you can resolve what it takes to communicate between me, you, and Lucky, um, there's lots of energy actually being used, and there's a server somewhere that's actually transmitting all these conversations that we're having to through different points, right? So it's leaving my house, going to a server, from the server is being distributed to you in real time, and these travels is happening real time. So this travel takes a whole lot of energy, and a whole lot of energy means when it combines itself, those energy adds up, right? So one of the ways to do that is to reduce the amount of data that is traveling from my house to the data server. And for the data servers to process that much data means it's taking that much energy for the data server to process that data. What the solution is that is being worked on, companies like Nvidia and others, is to say, how do I capture you as a person with your emotions that we know as a system that is able to capture those emotions and not actually transmit your emotions to the camera. So what Lucky will see is not the real me. And I'm getting into the territory of deep fake, but we can separate that deep fake from what I'm talking about here. Is that how do we reduce the data amount that is necessary for us to communicate between three of us? So what you will see as an audience through the laptop is not what I'm actually doing. So I have a hand movement that you might not see, but you will see the correct expression based on what it is that I'm saying.
Mm-hmm.
So in AI machine learning and the servers will know, okay, this is the data that came in. What I will process is his tone of voice, his emotion on his face, and show that to Lucky and Grant because it doesn't cost that much data to travel to your location, two different location. And by the time you see me, you hear what I'm saying, real time, but you don't see my facial expression in real time because that's the expensive part of the data that we're sending out to the server. And the server has to process that. Well, instead of processing all the video, can I just process the audio and a snapshot, like a sort of like a GIF of what you were saying and how to make those facial movement to fit the words in there, right? Now, I know that is a very real case that is happening because of deepfake, right?
Mm-hmm.
Deepfake is literally what that was based off of, right? Deepfake is for people that are listening. Deepfake is somebody taking my face and pretending to be me, or they did that with Justin, not Justin Timberlake, but Tom
Tom
Cruise.
Cruise. Yeah.
Tom Cruise, somebody from Netherlands, literally pretended like he was Tom Cruise and went around and did all this stuff, and people were just like, "Oh my goodness, Tom Cruise is cool." But he's like, "No, that's not Tom Cruise. That's me acting like Tom Cruise with Tom Cruise's face on a video."
Yeah.
Um, and the whole time he didn't have a mask on or nothing, so the whole video stayed with him. I mean, that graphic of Tom Cruise's face stayed on his face the whole time. So it's sort of like a filtering on Snapchat or TikTok, right? But at
Yeah.
the same time, this deepfake could be very dangerous. Like, say, for example, a world leader from a country like U.S. Could be used as a deepfake and sending out the wrong message to the wrong countries, making it an urgency that we probably don't need after COVID. All sorts of nuclear buzzwords going around these days. We want to reduce the amount of deepfakes for those kind of purposes. But I'm putting that out there because it's kind of like what the open AI industry is working towards. Now, I'll give you the example of GPT-3. Who owns GPT-3? OpenAI. And Lucky, like to your point, you mentioned Microsoft. Yes, Microsoft Cloud Service is what's hosting GPT-3's activities, right? So all the uses are coming from Microsoft Cloud Services. Who owns GPT-3 or who owns OpenAI is Sam Altman, right? He's the CEO, right? But Sam Altman got the investment for OpenAI for the reason of regulating AI, keeping an eye on AI development and designing, so that way we're not taking risk on developing an AI, right? So Elon Musk was the original partner with Sam Altman on this project, OpenAI. OpenAI actually has a bunch of Dale is OpenAI, GPT-3, GPT-2, OpenAI Gym. These are all OpenAI projects. So OpenAI puts it out for
Wow.
people to use. And Elon Musk is no longer part of that company, as I'm reading through the Wikipedia. Reid Hoffman, the co-founder of LinkedIn, is part of it. Peter Thiel, PayPal. A lot of big investors are in OpenAI, providing these services to people. And the purpose of OpenAI, the mission of OpenAI, which I knew for a very long time, is that OpenAI's purpose is to help developing artificial intelligence in a manner that we do not come to those nightmare scenarios. The nightmare scenarios of how AI will take over something or do something bad, good. I mean, we can go with examples of AI all day long. So,
Hmm.
just to finish off the statement about AI, that's why I like using the word machine learning. I like the word machine learning because it limits that imagination that can go run wild, right? Imagination about like AI is so wild, but when we start talking about machine learning, it kind of narrows the focus. It says like, look, it's not about that AI that you're so scared of. It's about machine learning, case by case, that is providing you with this unique experience that otherwise would be very difficult to do. Google Map uses machine learning. Siri, machine learning. Voicemail, machine learning. All this technology that is AI named is because wider population knows AI, but very few people use the terminology machine learning to describe an AI. Now, AI, in a sense, is combination of machine learning usage that provides that. I think I'm going to get the word wrong, but it's modularity that's coming together in order to provide a single experience like an AI, rather than to say, it's like, isn't it artificial intelligence? No, it's a narrow AI that has multiple machine learning built into it to provide a service or an experience or a technology that is AI like, right? So we have lots of AI like at this point. We have lots of narrow AI. The point we're trying to get to is AGI, the artificial general intelligence, where we will say something like, "Hey, remember the Star Trek episode where there was an AI?" Like literally, that's what we have with AGI. Right? One of the recent Star Trek series, all they literally talked about is a bundle of data that is traveling from hardware to hardware, and that bundle of data is the master algorithm, right? So the master algorithm, if enemy captures it, if anybody from future captures it, they will destroy the present. And if any of the enemies that we have in present time, if they capture it, they will destroy us, right? Because we are the owner and the keeper of that algorithm software, right? So this algorithm software doesn't really require hardware specifically. It travels from hardware to hardware, in order to provide the services that you need, like a master algorithm, right? So you can ask a question; it will give you all the history of the humanity. It will give you history of all technology, how to develop technology. It'll give you all sorts of insight that you probably don't have at this point, right? Um, but let me stop right there. I know when I'm talking about AGI because I always love bringing up Star Trek references, so I'm going to stop right there.
I love data.
I love
Data.
data exactly.
I love data.
Well, I
Uh,
wanted to, because the audience is listening in, and you've taken us in a lot of different areas, but I want to demystify some of these things.
Sure.
A machine is, artificial intelligence is software. That's what it is, right? And it is machines are very, very good at a couple of things. Two things that I've always known. Number one is communication. They're very, very good at communicating bits and bytes across the stream. Number two, they're very good at collapsing the window of time. That is why we utilize the machines that we do, because they're very, very good at that. When it comes to automation, they're very, very, very good at that. So people talk about, oh, this thing is going to, replace me. You got to think about, well, what are you doing that's so repetitive and predictable? Remember that repetitive and predictable, that it doesn't take a lot of conscious thought to make a decision. It's just very repetitive and very automated, and that's what will happen. Those kinds of things, that those are the types of things that will probably be eliminated because we have problems with shortages. Just like in healthcare, we have labor shortages. So you got to find ways to do more with less. If you don't have the manpower, you've got to find a way to automate it. So, for instance, when you're doing in a pharmacy, they have to do distribution of different medications. Well, you could have three or four people in the back room there filling in the bottles from the prescriptions that come in. Well, if there's a way that you can automate that, and take that information so it's automatically done, and that you can have a human to machine discussion about where you're at, that's a good thing. There's nothing wrong with it. We have to remember, why did we become so good in the 1900s? Again, because we were able, to automate the process of building a car. The Model T, they made an assembly line because it was automated. It was repeatable, and everybody had to do their little part. But we have to evolve as a people, as human beings. Like, okay, that physical part of what you're doing, that was repetitive and repeatable. Excuse me, it's kind of two things, but predictable. It was repetitive and predictable and precise. That can audit that will change because we don't have the labor to keep doing the way we're doing it now. So it's not really so much about replacing humans; it's replacing the humans that aren't there. We're replacing certain functions that we can't. I don't have 10 bodies; I only have 8, so I need to automate those other two. So let's step back from some of the sci-fi because we've scared ourselves. I saw Terminator 15 times. I know exactly what you're talking about, what you're trying to do here, guys. Skynet's right around the corner. Like, no, no.
I gotta say, Skynet is literally what the Chinese call their surveillance system. Skynet is the
right,
name
it
of
is.
the Chinese
Mhm.
AI system that uses computer visions to capture all sorts of information about the citizens that are out and roaming about in the street. So facial recognition is part of that AI, and Skynet is the name of that facial recognition system to penalize people for bad behavior out in the public, or even to ban them with social credit system. Right. So they, instead of have a credit rating, they have a social credit system that scores them on, like, can you travel in the plane or do you have to take the bus? Right. This is the kind of uh, uh, you know, crazy scenarios that we're thinking of. But like, look, let's get away from the negative. Let's get away from the negative. Let me talk about the pharmacy use case that you just brought up, right?
Hmm.
So what about 3D machine if they were able to create the pills that you need that you will order? Because instead of a pharmacy that holds the inventory of all sorts of pills, it holds the formulas how to create those pills in a 3D machine. And that
Mhm.
3D machine will take orders based on whatever the doctor pushes in. So, not only is it creating that medicine for you locally, and it's ready instantaneously to be shipped out in a mail, right? So there's a repeatable process that you're talking about, and then predictability of it. We can use predictability to figure out like what sort of medicine do we need to be in what zip code, what sort
Mhm.
of consumers do we have in those zip codes, and how do we get those additive manufacturing tools in the hands of that zip code, so that way that zip code has those medicine available. You're talking about something repeatable that is redundant, but that creates more job for people that are no longer working in a pharmacy. That creates that ability to say, how do you take your subject matter expertise as a pharmacist and add that to the development of AI machine learning? How do you become an engineer that is to say, I go from zip code to zip code and I make sure those 3D printing machines that are stationed in CVS or Walgreens is working properly and it's working to the level it's supposed to. How do I rate that? How do I write down the notes about how the system is performing? Because like there's a different types of taking notes, right? System can write a note, but system doesn't have the five senses that humans have. So a system will still need a supervision to be had, but for this 3D manufacturing, right? So it's about augmenting the experience of uh, people, right? The user. But at the same time, it's utilizing the subject matter experts to a level that they feel content with the services they're providing. So a pharmacist, I get it. It's exciting to get started on day one, day three, day four. But there must be days where you're just like, I've been doing this for years. Can I catch a break here at one point or another,
Mhm.
right? It happens. That's what happens with the repeatable process. It's not that exciting. And given the population decreasing in size, which is the geopolitical tensions that we're facing right now, where the population of each country is declining, and then a birth rate is declining with that, right? So now that you have less taxpayer and less people are willing to work, and because there's people that want to work, they want to have a meaningful work environment. They want to experience a life that is not a monotonous, repeatable, unpredictable kind of situation, right? Unpredictable is in the sense that nothing will change in this repeatable process. It will continue to repeat until the day I quit this job, right? So there's nothing really exciting to provide with your human brain power into this role. So yeah, you have shortages of worker and you have alternatives that you can use. But if you don't start early on, you're only going to come to the game late and somebody else will replace that business process of yours with something way better. And I'm looking at you, Blockbuster, right? I'm looking at you, Ford.
I want to be there.
I'm looking at you, BMW.
Yeah. That would be more like the human in the loop, the lone pharmacist where, yeah, I can see where typically you have four or five people running around, and now you have just arms moving, robots moving, things flexing and picking up pills, and at the end you have one human in the loop sitting there with his Coke, you
Right.
know, with the straw and just being there, pushing the button just to make everything continue to move in case they get jammed up, a little reset button, whatever. But
Reset button.
there needs to be a human in the loop. And you think AI is funny? There's a reset button, but just like we reboot our systems, AI needs to be reset to clear the memory, just like an
Just like,
application.
yeah.
I've seen it where personally where I'm using different models to train, and the fact that I stop and start the services and reset that AI, it'll give me a different output. It'll be on a different tone just because I changed, the timing of it. And so that we're noticing little things about AI during training. I'm noticing little peculiar things, about AI, and it's really at the end you start to wonder. It's like, okay, we're going to control this. I know we are, but it's amazing how we go from machine language, just bytes, ones and zeros, doesn't have any color. We just know it's happening in the background. And then we see AI that has imagination like DALI and Mid Journey and Stable Diffusion, those types that give you iterations. I've used it where I used I wanted to do iterations of of artists that obviously they're past, they're dead now, but I want to see what would they done if they would have saw father son fishing, and what type of theme they would have created with father son theme fishing with like Pablo Picasso and Rembrandt, and you start to see the imagination of a computer where that, you know, it's amazing how we've gone from nothing to, in the past 3 years, elevated the technology now, and it's available for everybody.
Mhm.
So machine language is more ones and zeros. It's still hard to put your finger on it, what that is if you're from the outside. But us nerds, we know, okay, we can throw machine language at data and we can start to get information back, classifications, forecasting, estimations, associations, things that are statistical, but they don't feel like AI. But there's things out there that feel real now. And I think those are the things that we need to really pay attention to, like Skynet. Did Google design Skynet, by the way? Does anyone
No,
know?
it's a
Here's
Chinese
yeah,
company.
where you guys are going. This is where the intersection or the crutch, the conflict resolution will have to take
Yeah.
place. Is when the technology becomes more advanced than the technologist. I learned that from Christopher Lafayette. And the reason why that could occur, because you have to remember the technology, the way we're building it now, is a collective. Here's a true fact: a very smart individual might have an IQ of about 150. That's a lot.
Right.
A AI engine has an IQ of about 10,000. And that's
For sure.
because it's a collective. It is taking the information that has been put into its database, which is like its mind, and being able to manipulate that information very very quickly. Remember what I said about communication and time. Doesn't mean it understands it like consciously, but it's been giving the decision making mechanisms to come up with information very very quickly, much quicker than you can with your human mind. So going back to what I said about when is the technology become greater than the technologists. Here's where we need to look at ourselves and what we're doing. This is not a time to like, well, I'm not gonna either you could sit around your home and your couch and become a couch potato, and then you no longer use your body, and then all of a sudden you no longer use your mind, right? You no longer use your imagination, and then now you're just about useless. Right? Right?
Warning,
So,
warning, warning.
warning, big
We're not.
time.
Listen
No,
up.
no, no.
I think
Hey,
we're there.
listen up, listen up. And the reason I say that is because when you
Yeah.
look at what's really coming up with Web3 and what's coming in what you call the metaverse and this new environment, new platform, the engine, the what it takes to be successful in that platform is creativity. That creativity comes from you as a human being. You control, just like a car. You drive the car. You don't, the car don't drive you. So be careful. If you're driving the car, you're going to be very successful, and you'll be your imagination is going to grow, your creativity is going to grow, your skill sets are going to grow. If you utilize the technology very negatively, and I don't, not speaking on what the Chinese are doing and what they're not doing, but if you're just using to try to control people and really really put them to sleep,
Yeah.
basically, because that's what you're doing. You're dumbing down their subconscious, you're dumbing down their conscious, and they're just they are the robots. And again, if the
Yeah.
technology is controlling you, then you have to step back and say, I got a problem here. But the problem really depends on you. You as an individual must learn how to first utilize the technology, just like your cell phone. You utilize the iPhone, but you can see it can get addictive when you're going through social media. You've got to be able to know how to shut it off, shut it on. You got to know how to say, you know what, I don't like that feed that I'm getting. I don't want that, because the AI
Right.
doesn't know that it's negative. It doesn't, because it's not a human. It's not conscious. It's just saying, hey, I clicked on this particular YouTube clip. Now you're showing me 100,000 of these things. Like, I only needed to see one. And that's what I'm saying. It is a machine. You see where I'm
It
Yeah.
going?
knows that its intention and mission is to keep you on YouTube. So it will provide you with whatever keeps you on YouTube, not whatever makes you
Mhm.
smart. Now,
Yeah.
I think, we had this conversation when we talked about social media and mind numbing effect of social media. Like you're saying, technology, if you're using it, let it empower you rather than to, take the power away from you, right? Which is
Right.
that social media, there's not much in social media that says, I want to inform you about what's going on in the world. Social media is built for the purpose of keeping you on the platform for as long as possible. So combination of amount of hours that people spend in the social media increases the value of that social media. As in monetarily, they can say statistics will say Facebook users spend less time in Facebook than TikTok users do. So which one is more valuable? TikTok. TikTok doesn't have content that's better than Facebook, or Facebook doesn't have content that's better than Instagram. Nobody has any content that makes you a superhuman. It's just that they're using your hours in the day in order to profit and maximize their statistics that says, if I advertise in Facebook, I'll pay this much. If I advertise in TikTok, I'll pay this much. Google, a little bit less because it's not so much concentrated on content and advertisement, right? So I want to kind of, take your thoughts on this ability to say, like, you mentioned predictability, um, like, and a repeatable process. So I think in the human brain, we have a repeatable process that is continuously happening. And that repeatable process is what we're trying to align in machine learning neural network, right?
Mhm.
The neural network inside of machine learning will do the same neural network activity that we do in human brain. In human brain, we have five sensors that are providing all the data that we need, and the brain is processing it. But the first key steps to that five sensors data processing is that brain identifies it through the five sensors. Right. Once the data, all the stuff is processed, all the sensors are feeding into the data. Data is being processed in the brain, and that brain processing allows an identification. So you identify, and you label it. So our brain is continuously identifying, continuously labeling. It's a repeatable process. And
Mhm.
it's not meaning to like say, I identify somebody or something. I'm talking about identifying the most mundane thing ever, right? As in, like, what's the temperature in the room right now? My brain has identified that, but it doesn't necessarily become part of my decision until that labeling changes, right? I identified this room is getting hotter. Let's turn the AC up. That's a decision. But that doesn't mean that was the only time I ever identified. Well, no, the brain is continuously identifying, continuously labeling. And if we have to make decision, we come to the conclusion of yes and no, right? But as we make decisions over time, we do better predictability. And
Mhm.
that's what the similarities in machine learning that we've been talking about for a long time, almost 53 minutes at this point, is to say, how do you improve that machine learning? Well, you give it a lot more decisions to make and better predictability.
Yeah.
Once you give it better more decisions to make, it does better predictability, and it serves you with better purposes. You give more experience out of it. You know,
Right.
you mentioned earlier about accuracy. System that we have in place right now
Mhm.
has high accuracy, but it has no confidence. A machine has high number of accuracy, but also high number of confidence, right? So the word is highly accurate and most confident. As in most confident, as in like I'm 98% confident or 58% confident that the decision I'm about to make will be a good one. And if I do make that decision as a machine, even if I get the wrong one, I will fix it next time because I'm making more decisions, and with more decisions, I get better predictability. So those three keywords is identification, labeling, and decision making, right? So as we
And
do
let
that,
me say this, what you're
we
saying
get
is
better.
so important because that's the basis, that's the
That's right.
framework, right?
Framework. That's
But
right.
let me tell you what the limitations are right now. It's just like when you are typing text on your phone to somebody. The AI is trying to predict for you what you're about to type. We've seen this happen a lot of time. That's why you even have this disclaimer now, about typos. I didn't mean to
Autocorrect.
say that. Autocorrect is almost it's good. It's not all the time
Uh,
correct. This is the thing we need to understand right now. The machines don't know that it's wrong. It can only make a recommendation. Remember what I just said. It's making a recommendation that you can either decide to use or not use. It is not the last straw in the decision making process. As a human being, you are a part of this program, especially in the AI space. So think about what I just said, because right now it's not completely accurate. Even when you do text to speech, it's not completely accurate. I will say it'll get more accurate over time because it will have more data and more compute power because it has more reference points to draw from, and it becomes better. We're not there yet. We're not there yet. Well, I'll say my conclusion is this: as the human race is concerned, we must evolve. We must get better. We need to be more conscious. The seat of consciousness is not in our analytical ability, it's in our creativity. And that takes an awakened state of mind. And the more awake we are, the better we can then utilize our technologies to move us along our destiny. That's what I will say.
Well said, sir. Well said.
Yep.
I think we started this podcast with lots of cheers about ay 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 ay, and we kind of had that little scary moment like ay 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 ay. Now it's more like
It
back
can
to
be.
that ay 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 ay. It got this. We can do this.
We can, but it is a challenge. Don't get twisted because you could
Don't
have
get it
that
twisted. It's a lot of
scenario
work.
that it's in control. You don't want that. You
Yeah.
don't want that. You want an augmented reality. So it's helpful.
Ooh, well, I will end it with that. Like that is the key component of everything I'm trying to do at this point is to encourage the workforce, not a techie, not a technologist, not a data scientist, not a machine learning engineer, but the workforce to understand just what you said. You have to create a system that augments your ability to do the job. Once you do that, you extend your workforce, you expand that workforce because now you're augmenting, AI is augmenting your job for you. So you, instead of shrinking the workforce, you want to expand that workforce, right? Instead of taking the humans out of the workforce, you want to add more humans to it. And that is reality because the number that we're crunching right now, it's talking about 98 million more jobs coming into the market in the next 10 years. But unfortunately, we don't even have that many bodies to actually put into the work, right? So like, we don't even have that much labor left because a lot of people that are coming into the work system right now, they're going to get into the rut of this repeatable redundant process, and there will be 98 millions opening, I'm assuming, that will lack majority of the people to work on those fields, right? So machine learning engineering is like a top educational priorities for many industries, but school wise, there's not enough production of machine learning engineering students, right?
Mm.
So I really want to put that out that the workforce needs to be involved in developing an AI so we can create a workforce that is augmented by an AI rather being controlled by an AI.
Exactly.
Thank you.
Thank
I
you.
agree. You guys
So
hit it on the
Lucky,
head. I'm just gonna agree with you guys and say, ay 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 AI.
how about you, Grant? Let's give it a shot.
Ay, 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 ay.
Oh yes, I love it. I love it. Ay,
Uh,
ay, 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 ay.
that's our
With
charge
that,
in, man. We got to get it.
Gotta
with
get it,
that,
man.
thank
This has
you
been
all very,
thank
very
you
much.
for having me, man. This has been awesome.